Hey, hi guys. Uh, Today we will be revising the so-called our wait, mm, wait. Let me find. Yeah. So this is the topic we are going to study today. This is the power diode topic, and let's see. It is a power diode, and we have anode, we have cathode, and there is anode obviously p plus side and n plus side obviously diode, and there is a drift layer. Okay, there is an drift layer. Drift layer, we'll understand what why this drift layer is introduced. First of all, power diode has vertical orientation. Okay, so power, oh yeah, we can say power electronic device. That means power diode, power MOSFET, then BJTs, power BJTs, and all this stuff, IGBT. These are power electronic devices, and they have vertical orientation. Okay, so why this vertical orientation is there? Vertical orientation responsible for high current rating of device. Why high? How is it possible? How it is uh like how it is responsible for high current rating of the device? So if you have like vertical orientation, then the cross section area is more. If the cross section area is more, then what would happen is that the see, if the cross section area is more, then the current will be more, it will flow more. Yeah, so if there is as much a conductor and something like this, and more current will flow. If small and there is small space, less current will flow. That is why it can increase the cross section first of all. Then we can say cross section area increases. That is why current rating increases. Matlab, more current will flow. Okay. There is a drift layer also. Why this drift layer is there? Drift layer helps in, see, drift layer is obviously right lightly doped n minus region. So n minus region is something will have less charges, and its doping concentration is low. So the breakdown, that is avalanche breakdown, will be more. Avalanche breakdown will be more because it is inversely proportional to the doping concentration. So it is less, so it will be more. So the breakdown will be at higher voltages. What the breakdown voltage will say? Breakdown voltage will say that this voltage rating is more. Then that means we can run it at higher voltages. Got it. Drift layer, lightly doped region in the power electronic device inserted to increase voltage rating increases. Yeah, breakdown voltage obviously. Lightly doped, which makes breakdown voltage increases, and which In return, that increases the voltage rating. Oh, obviously. What is the signal diode and power dot lightly doped region called drift layer? Drift drift region is inserted between P and N in plus region. Yeah, more cross section. And device has vertical orientation, more cross section area, so higher current rating. And so see, it is in milliamperes, volts, and millivolt. It is amps, kilo, and watt and kilowatt. So obviously the rating has obviously increased. See, if you see, like the voltage rating and the current rating has increased. Okay, so it increases to milli to amp and volt to kilovolt. Obviously power will be kVA, rating will be milliwatt to uh watt to kilowatt. Yeah, so that is all. In charge neutrality condition, what is this charge neutrality condition? Number of electrons, number of holes equal, recombining, form depletion. Obviously they are recombining, so there is no movement, there is only recombination, there is no addition or injection or removal of charges. There is no uh, there is nothing. Yeah, so concentration per semicube per semicube, so we have to add into area into length, so and into E. Okay, yeah, negative ion charge, positive ion charge. Okay, so ouch, this is the thing we have made. So if doping the ND is less than less, that means the NDD means donor. Donor means inside has, let's say, less concentration than the B side. Then what would happen? There will be XN less than, so it will be less. So XN would be greater than XP or less than. As ND is less. ND is less. It's less, so it is, what would be more? I think. Yeah, I think. And so xn would be more, and if xn is more, what does it mean? If the concentration of that is side, let's say n side is less, then yeah, so width will be more. That means more depletion layer would be there. Okay, so that is the stuff. That is charge neutrality. What does it says? What does it say? Not neutrality means obviously number of is in the negative charges equals to positive ion charges. Okay, number of electrons and number of will be the same. So n negative charges will be negative. Donor, that doesn't matter now. Let's say Na e, yeah, so charges. And acceptor, we can accept uh yeah, so acceptor would be like mm, whole whole side. The PNP would be better now. Right, acceptor. Accept means we can accept, we just free, like which can accept, which can donate. So donate. LL would be X P, and here would be XN. Why? Donor. Which can donate. Donate means light cell electron. Okay, think of P N N P NAND P and inside lightly doped ND less than NA, ND less than XN greater than XP, and depletion with inversely proportional to the doping concentration. What does it mean? So more depletion with in lightly doped region. Okay, so that is all. And I want to know the characteristic of a power electronic devices, then you can understand that also. Okay, so what is happening here? If you see, there is a okay, so there is a breakdown voltage inversely proportional to the concentration. So drift layer D low and D is high, obviously. The breakdown would be more high. Yeah, so avalanche breakdown will be at higher voltages. Voltage rating is high, obviously, lightly doped region, obviously, and at some knee voltage after knee voltage, we have just it's not breakdown. It is like exponential current increases drastically because no depletion layer vanishes. We can say it is exponential in the signal diode, and the rating is obviously milliamperes. Oh, yeah, and there would be ampere obviously current rating increases due to vertical orientation of the uh, power electronic devices, and linear due to drift layer. Okay, power diode. Okay, in drift layer doping concentration is low. Okay, charge concentration low, sigma low. Yeah, okay, sigma is low. Yeah, so formula is like something like sigma's formula n e n something mu p, something like mu p plus p n mu n, something like this. Yeah, so the drift resistance is high, drop in drift region, IR dominates. Okay, exponential characters like the loss drop due to high resistance drift there has the resistance high, IR dominates exponential characteristics. Okay, so I understood. Conduct, yeah, I was telling you this formula about this formula. We know N is I think concentration, electron concentration, and holes concentration is mobility, like how mobile it is. Okay, yeah, conductivity of a circuit. Okay, I will get into this also. This is also a very important topic of conductivity modulation, but let me write it in my note. Okay, wait. Yeah, so now let us move on to the conductivity modulation. What is this? So in this, what is happening? You know about the sigma. Sigma is like conductivity, resistance, inverse of resistance. It is the formula that is E electron electron concentration, mu n mobility of electron mobility, plus P as holes mobility, and mu P as mobility of holes, concentration of holes, hole concentration, and all this thing is a sigma conductivity. Okay. Now, since drift layer is slightly doped, got it, charge concentration low, drift region, and hence sigma low are high. So what is happening? Drift layer has low concentration of charges. Got it? Okay. And that is why sigma is low because it is directly proportional, and R is high because it is inversely proportional to sigma. Resistance reverses high, then conduction losses will be high. So the conduction losses will be high. Yeah, I'm making the short notes. If you need it, please comment. I will provide it. Then during forward biasing, what is happening? Majority charge carriers diffuse into n minus region. Okay, during forward biasing. Okay, you are forward biasing. Majority charge carriers. Yeah, diffuse into n minus region. So I'm forward biasing it. Yeah, it is forward biased. So what is happening? Like it would push the holes from p side and electrons from n side, and it would accumulate, and obviously charge concentration will increase in the drift layer, and also sigma will be high. Why the sigma would be high? Sigma means obviously it's directly proportional concentration, and for drift layer this is the called the conductivity modulation, and it is R1 will be less, conduction loss would be less. This is all this is the con conductivity modulation. So what is happening? Let me draw it. So we have something called our power electronic diode. We have P plus region. We have N minus region, which is called drift layer, and we have N plus region. We are just trying to bias it, and the holes would be pushed to the drift layer, and electrons also would be pushed to the drift layer. So here charge concentration high in the drift layer, sigma would be high, and the R on will be low. Conduction loss will be very low, and this phenomena is called conductivity modulation. Okay, now the switching characteristics. It is very important. Switching characteristic. Okay, let me understand this topic also. As the forward current starts to flow through the device, charge flow between anode and cathode. Anode obviously at the P plus region and the cathode would be at the N plus region. Uh, Initially resistance of drift region is high. Yeah. Due to which forward of device is dominated by IR drop. As the forward current reaches peak value, forward voltage IR becomes maximum. When forward current is established in the device, then charges is in large number are entering drift layer. This low, this high, and hence forward voltage that IR would be low. Hence forward voltage across device also falls. Yeah, what is happening here? So you are increasing the forward current. Like forward current means you're forward biasing it, okay, and you are passing the current, or we can say, yeah, so current is first in the forward bias. So when the, so there is R high, R will be obviously R high in the drift layer because their concentration is very low, sigma is high, sigma is low, R is high in the drift layer initially. So there will be, like, it is trying to increase because I is also increasing, and after some time it would achieve its maximum when the current is also high. After that, all, like, lot of charges will accumulate in the drift layer. So what would happen, you just have lots of charges here in the drift layer, so the sigma, that is the conductivity, would be um very high because concentration of charges are high. Then what would happen, the R on would be low, and that is why it just dropped. So that is the turn on characteristics. And turn off characteristics, if you want to understand, turn off characteristics, when we turn off a diode by means of external circuit, then forward current starts to decrease. Obviously there is some external device, obviously we are doing through external device only, we changing the polarity, we just reducing the current until current reaches zero. We can say forward current through the device, yeah, until it reaches zero, forward current is flowing. We just we forward current is reducing. Here it is zero. Up to here forward current will is flowing. Yeah. Then in order to turn off the device, we need to increase depletion width by removing holes from p side and electrons from n side. This is called as removal of excess charge carrier, and it requires flow of reverse current. Yeah, that is happening also here. You're 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 reversing the current up to a characteristic forward current flows, so no depletion layer is present. As current becomes negative, depletion layer starts to form, and after some time reverse voltage appears. This process of removal of stored charges in device to form depletion layer so that the device can block reverse voltage. It's called reverse recovery. Okay, reverse recovery time is the time from which reverse current starts to flow. Okay, reverse recovery time, because recovery time is the time from which reverse current starts to flow to the time current reaches 25% of the maximum reverse current. Yeah, so what is happening here? If you see, we are just reducing the current in the reverse. Obviously, we are changing the polarity, and up to this zero, there is no formation of depletion layer. Yeah, so it is only forward current only flowing. After that, there would be flow of negative, that means reverse current, and depletion layer would be formed, and here would be charges are being removed. Charges are being removed. Depletion layer formed and no more charges are removed. Like depletion layer is formed and is the maximum. You can't form bigger than this depletion layer. So the maximum current. Then it would recover to up to zero, or you can say 25% of reverse recovery time. Voltage is up to this. Okay. Okay, so the removal charges uh, to form depletion layer, device can block reverse voltage. It's called reverse recovery. Yeah, so removal of the charges we can say. Reverse recovery time is the time from which reverse current starts to flow. Okay, is the reverse recovery time to the time. Uh, yeah, so negative current is reverse current starts to flow to the time when it reaches 25% of the reverse current, we can say. Reverse current means to minority carriers. To minority carriers. Okay. di by dt is IRM by. Acha. Change in current with respect to time is I by this. You have done this. So IRM is di by dt TA. Okay. Area under the curve. Charge removed during reverse recovery. Okay. Yeah. So charge removed is half into base into height is something, can think of a triangle. So there is a softness factor which is TB by TA, and soft recovery means 1, and snappy means less 1, very less, snap, fast recovery, you can say. Oh, TB is STA obviously, so we can change TB as STA, so 1 plus S, and we just IRM changed to this, TA is changed to this, and charge removed formula we have made. Types of power diode, general purpose diode, studied just now. Okay, slow device because US recovery time takes too much time. Snappy is less. One, we can say snappy, and there is one soft and snappy. SS, soft. Okay, yeah. So PCC, fast recovery diode. Okay, it is beta 5 milliseconds. Uh, Schottky diode, inverter stoppers, metal semiconductor. Majority means one. Acha, if you want to reduce the time, now you have to uh like the rating should be less. The rating should be less. Okay, small depletion layer. It's a no depletion layer. Majority carry reverse, semiconductor, metal semiconductor. Yeah, we know that majority carrier device is no depletion layer, small. Yeah, because yeah, so switching frequency high. PN junction is no conductivity modulation. Why? Because there is no PN junction, there is no formation of depletion layer. There will be no, like, you can't form charges and all. R1 will be high and the conduction losses will be high to maintain same conduction loss. I rated should be low. Yeah. So conduction loss should be rated. I rated should be low. Low power and high frequency application like MOSFET and Schottky diode. Okay, obviously. Minority carrier device are obviously there would be PN junction depletion layer formed. T on T off is high, switching frequency is high. Okay, losses would be also high. Yeah, switching frequency would be low, obviously due to conductivity modulation iron would be low. Then conduction losses will be low. For same conduction loss, I current rating would be high now. High power and low frequency, like rectifier stuff. Rectifier is low frequency, but the rating should be high. That's all. Hope you like this video. Unders for understanding the topic. Uh, it's a very interesting. Power electronics is bit theoretical, but it is interesting if you try to understand it uh, fully. This is for today. Hope you like this video. Like, share, subscribe. This is the new playlist we can say we have formed. This is the electrical subjects we will cover, and we also have the coding part also. We will do both. Yeah, this is this will be doing like reading stuff, understanding stuff, and because my engineering is electrical engineering, and I'm liking the coding also, so I will cover both. Uh, try to cover both. See, learning is not don't I'm if I make this type of videos, what happens? I I try to teach you in that process. I also uh, learned stuff. Like if if it helps me. So uh, and also I'm teaching my communication skill also increasing. It is not like that. Communication skill is also increasing. My learning is also happening. My time is was not also wasting, and like it has positive sides, and I'm like posting it. Might be someone who need this, who need to read with some person. So I am here. No need to worry. Hope you like this video. Like, share, and try to comment. I'm telling in my all the videos because might be someone watching this video. Hope. Bye.